Okay, welcome back. In this problem, we have two boxes that are sitting on an inclined plane connected together by a string or a rope. And each of them has a mass of 5, but they have different coefficients of friction, which means they must be made out of different materials. And the coefficient of friction of this one is 0.18, and this one is 0.29. So the first thing I'm going to need to do is to figure out the friction that's happening with each of these boxes. So to do that, I'm going to start with this one down here, and I'm going to do just like a traditional inclined plane problem, where this is FW, that'd be 5 times 9.8, that's 49. And then I have my FN, and I have my FP, and obviously my FN really points up. So this is Fn, this is Fp, and then this becomes Fp here. So I would number crunch all of those, where Fp is Fw sine theta, and that turned out to be 20.71. And this is Fw cosine theta, and that was 44.41. And so friction is going to be mu times Fn. And now that I have Fn, I can find friction. So the friction for this particular box turned out to be 7.99. So since he wants to go down, his friction is going to be going the other way. So I'm going to actually put it like this. So this friction would be 7.99. And then I have the same thing happening over here with this box. I have FW, and I have FN, and I have FP. So here's my FN, here's my FP, and again, the real FN goes up. But number crunching wise, since the block has the same mass, FW is the same, and it's the same angle, so FP is going to turn out to be the same FW FW sine theta. This is 20.71. FW cosine theta, this is 44.41. But because he has a different coefficient of friction, his friction number is going to be different. So when I number crunched the friction, I got 12.88. So I drew a big picture here because there's kind of a lot going on in this picture. But the first thing I need to do before I can find the tension in this string, which is really what I'm trying to find, this tension here, is I need to know the acceleration of the system. So I'm going to do the same thing that I always do. I'm going to talk to myself, and I'm going to say, what would be making this system move? I'm going to draw this FP like up here. So I have an FP from this picture, and I have an FP from this picture, and those are the forces that are making the blocks want to slide down the plane. So I have FP from the first one, plus I have FP from the second one, and then we subtract off any friction or any blocks that we're dragging. So we're not dragging any blocks like over the edge of the inclined plane. So we're going to subtract off the friction for the first, subtract off the friction for the second, and that would be M net and A. So we would have 20.71 FP for the first one, FP for the second one, minus friction for the first block, minus friction for the second block. Add the two masses together, and then we can find the acceleration, which I got 2.06 meters per second squared. All right, now to find the tension in the string, I have to draw a free body diagram of an individual block. Honestly, I could choose this block, or I could choose this block, and I don't know why, but I chose this block. And so if I drew that block, so if I redrew that block down here, it's like, what is happening on that block? Well, one thing I see going backwards is friction. I see FP going forward. That is 20.71. And I also see this little piece of string going forward. And that little piece of string is going to be the FT that I'm solving for. So when I do F net equals MA, F net equals MA, I know since the system is going down that these arrows have to be, the sum of these arrows have to be bigger than this. So that's going to be FT plus 20.71. We'll subtract off that friction. And that's the mass of just this one block. And then the acceleration of the 2.06, which is barely going to fit there. And then I can solve for that tension, and I got 2.45 newtons when I did that. So I like this problem because there's kind of a lot going on, and you can see how we kind of have a double incline plane problem happening here.